HBM.
Uh, Medium to low, not tight.
Hmm. And your view, what's the delta between your view and others who view it as tight?
Well, I think the people who view it as tight don't understand how it's made. HBM is just stacked DRAM. So as long as you have extra DRAM wafers, and we obviously do, you can get a DRAM stick. It's very expensive. You can make HBM, and that's a big reason why people are very careful with expanding the supply because 60%, I think, of DRAM wafers right now are going to AI, which is HBM, more or less, right? That's what's actually causing this DRAM pricing, like commodity DRAM, to spike so much because you're stealing wafers from one share of the market to give it to the other.
Hmm.
And that's why HBM prices are probably like middle to low. I mean, also there's a couple vendors. Samsung and SK are obviously the highest quality. Micron makes some HBM, but people will source from whoever they can get. Um, you need it if you're doing AI, right? So that's why I think the HBM has less pricing power than DRAM. And if you look at Samsung and SK in particular, if you look at their profits, almost all of the incremental profit gains is not from HBM. I mean, there's a little bit, but it's like 60% of their increase in profits is from DRAM, DDR
Hmm.
memory, right? Just basic DDR sticks. And it's because we're eating that supply to make HBM. So HBM is medium to low. Like we can expand it still. But when you expand it, you steal from someone else, more or
Hmm.
less. It's a fixed pie for now. We'll see if anyone brings on supply.
So HBM medium to low, DRAM would be high then?
Oh, DRAM's the worst. Yeah, yeah.
Yeah.
DRAM as far as like some kind of, I mean, maybe there's other niches. DRAM's really bad right now. And DRAM's probably gonna get worse. So
Hmm.
that's the scary aspect because of the dynamics I just shared is like if you want more AI accelerators, you need more HBM. Every time you create HBM, you take away from DRAM supply. So
Why
it's going to create more and more of a shortage.
why are they making more incremental profit from DRAM than HBM? Are they just selling a lot more DRAM than they
Price,
sell HBM?
price gouging. It's literally that's stupid. It's
Hmm.
literally like the price of your 16 gigabyte stick went from $100 to like $1,000. Like, and HBM prices are pretty flat or somewhat up.
Why has the price, like if they both kind of, they both utilize DRAM, why has HBM gone up less proportional to DRAM itself?
Well, think of it like this, like to make HBM, you just have to take DRAM wafers, cut them up and stack them. So there's some packaging which creates a premium for the price, but you always know you can expand. We've only eaten up about 60% of the DRAM wafers. We still have a little bit more we can chop down, right? So if you do get a new order for, I don't know, Amazon or Google says, "Hey, I need some more HBM, Samsung." Well, Samsung says, "Well, I don't need to charge you more because I can just take from this pile and just pop, pop, pop. There you go. There's the price." Meanwhile, with DRAM, it's just a structural shortage. Like, you come to
Hmm.
me and you ask for it, and I'm like, "Well, sorry, I can't meet your demand." So it's
Yep.
who's ever the highest bidder. With
Yep.
HBM, I can meet your demand.
And then does making more DRAM capacity that takes a long time and not many players kind of thing?
No, no. It's a cartel. I don't sadly yes, there is some time frame for expanding capacity. Like DRAM's easier to make than HBM for obvious reasons. DRAM's a component in HBM. But no, I think the big cartel, which is Samsung, SK, and somewhat Micron, they don't want to. They like this. They like having high
Mm.
prices. They like having control of
Yeah.
this market, and they are scared because again, when you make a new like what I think what a lot of people don't understand in semiconductors is like you want to expand supply. Okay, what does that mean? $100 million machine, one of them, an ASML machine, right? Who knows what other you might need like some deposition tools, you might need other tools for like testing. So all that CapEx, once you do it, it sounds like it's a one-time cost, but running those machines need to run 24/7, or else they're not economical. So you think, okay, it's just some upfront money. But what they're thinking in their head is, I have to keep this running 24/7 to get back my money. And if I'm running this
Mhm.
24/7, I'm flooding the market with supply. So
Yep.
they are very, very scared of adding supply to the point where I read that the big technology companies, let's call it like Google, Amazon, Microsoft, they've went to SK Hynix and they've said, SK, we will finance the lithography machine for you. We'll put up the money as long as you give us a contract price for the DRAM you're going to make with it. And SK said, we'll think about it because they want to keep the price high. They're not dumb. They know 60% of their new profits have come from DRAM. So DRAM is like we're literally in like this shortage. I think it's obvious now DRAM costs more than a CPU. Almost any CPU, unless you're going like crazy epic server, but even then it's getting close. Because those servers, you need like 768 gigabytes of RAM to even make it worth your while, right? So
Wow.
it's literally crazy. It won't last forever. And another thing, which I mean, we mentioned it earlier off camera, but another thing that I'm thinking is if anyone does bite the bullet and expand supply, we will start seeing signs of that towards July and the beginning of fall.
Yep.
But my view is just supply is tight right there.
Yep.
Sorry for the whole rant.
Multi-year period before the supply becomes not tight.
It'd be a couple of months. I think six. I think by the start of next year, we'd have good signs of is supply going to weaken.
Yep.
Maybe in the summer we start getting signals where I would be scared to just be long SK and Samsung because again, that's where they're making their money. Um, yeah, so we'll see.
Yep.
These timelines take a while in lithography. So,
Next one, silicon photonics, optics, CPO.
not tight anymore. I honestly, it was tight probably at the beginning of the year because there was a procurement cycle for these CPO switches, which is Nvidia Spectrum, and I think Broadcom has some Tomahawk switch that also does CPO, and they were procuring a lot. I think right now you procure parts, you can go to Coherent or Corning and get fiber. The interesting thing about optics, which I feel like is a bit different than DRAM, is like it sounds like it's a commodity. And also, you mentioned quite a few things there. You mentioned CPO and I think a couple other things. It sounds like it's a commodity, but the pricing difference between like a quality part, which we can mention Lumentum here as an example, like Lumentum's lasers are the most highest quality, mean they have the least amount of noise or narrowest wavelength. That's ideal if you're going to be doing this silicon photonics and co-packaged optics. Honestly, if you can't get those kinds of lasers, you really can't pull it off. So in a
Mm.
way, for high quality lasers, applies medium, right?
Yep.
But people have already kind of done procurement, and we're going to see at the beginning of the next year how it goes when they actually start deploying these switches in, the data centers, and we'll see. My view though is silicon photonics has not just silicon photonics, but let's just say co-packaged optics and everything around that. It's kind of known to be not as reliable than pluggables. There's other benefits. Pluggables are commodities. There's like all kinds of pluggable companies, right? And they all are pushing prices down. But with these lasers, like Lumentum's lasers for co-packaged optics, silicon photonics, the laser is very likely to fail when you start delivering these systems in
Mm.
a co-packaged optics, and they need to be replaced.
Mm.
So in a weird way, because they make those high quality laser and the laser is one of the first things to fail in photonics and co-packaged optics, um, it's kind of like we will see if like they end up being bid up because there's not really many other competitors in the game right now with their quality, and they need some reliability. So there may be like a reoccurring like bid on some of those components. Now, when you mention co-package optics, well, it's harder for me to give you that view because there are a few foundries now. It's not just TSMC with Coop. That's their offering. There are others now. Like Tower Semi is like the big, they have an indium phosphide kind of node that you can use. So I think over there, the supply isn't that tight, and I think it's actually easier to fab some of these nodes, like indium phosphide nodes, that you would need for photonics rather than logic, right? So we'll get a bit of competition there. The real question will be like the lasers, right? Are those gonna fail? Any kind of small components. I'm not like a photonics expert, but there's like ring modulators and all this weird, wacky shit. So we'll see like, all right, are those bid up? But the actual like fabs, they can expand capacity quite a bit, and they are. So
Yep.
it's a good place to be there. They are ramping up. We will see if the lasers are good and the testing and co-packaged, capacity is good, right? So
Yep.
we'll see there.
Next one, advanced packaging.
Ooh, incredibly tight on TSMC, not tight on Intel.
Nice. Yep.
Oh,
Nice.
yeah, I think Intel's ramping it up, and we know there's a few customers that are definitely interested. I
Cool.
don't have any insider info, right? People might think I'm just so close to Intel that they're telling me stuff. They're not. They don't talk to me at all. But my guess is, we've already heard the Apple announcement. There's probably a Google TPU announcement coming soon. So
Cool.
we will see. And I know the Google folks are very, very into Intel. And I think Intel's packaging is I always try to make this point to people. It's like comparing TSMC's CoWoS to Intel's eMIB-T right now is like comparing like a semi truck to like a Ferrari at this point. It like they're so far ahead. And if packaging is really the next Moore's Law, which I think it really is, and it's really how we're going to be scaling compute from Rubin to so on, right? I mean, today's the Cerebras IPO, right? So I mean, like not saying like Cerebras is going to win the game, but we need more silicon area because we can't shrink the transistor. So they're definitely right directionally. Um, so yeah, I think on TSMC you're absolutely cooked. It's already pre-booked out. Most 60% of it's on Nvidia. The rest might be AMD and others. So yeah, it's tight there. You got to wait till
Mm,
probably 2028 to start getting any kind of capacity. But if you want to get some capacity on Intel, call me. I'll make a call and I'll get you in touch so you can get all the capacity you need.
nice. Next one, AVF substrates.
AVS substrates. This is the substrates for packaging or something else?
It's like bottom of the chip, I believe.
Okay,
ABF.
I couldn't tell you exactly,
Cool.
but I feel like more commoditized at this point.
Next one. Now, this is obviously a future thing, but high bandwidth flash.
Well, it's probably the worst because we don't have it yet. I think when it comes to market, Sandisk and SK will probably have like a 1 or 2 year monopoly.
Hmm.
And it's a very interesting thing to see who comes in. My mental model is that high bandwidth flash is a lot easier to make than high bandwidth memory, and you don't need the same amount of quality. So there probably will be a few people who try to come in if it's successful. I
Yep.
know Kioxia, which is in
Yeah.
I believe Taiwan. Um, they're looking at it and they have an idea, but I don't think it's quite the high bandwidth flash that SanDisk and SK are working on. And I think I'm very excited to see what comes of it.
And other people's view is that there's like reliability concerns with HBF, but your view is there'll be hardware and other solutions for that over time, and it just is not going to be as big as a concern as people feel, basically.
I think the concern that people have is that like write reliability specifically. And if you start thinking of this as like an HBM on the GPU accelerator, that is a fair critique. You know, your package there, but eventually your memory fails, right? Because you've written too much. Now, if
Yep.
you think inference is more important, that doesn't really matter as much, right? Right, reliability. We'll just load like all your weights there or whatever we need, and we'll just read it, right? If also though, I think there's this misconception that it needs to be packaged next to the compute dies. I mean, at the end of the day, it's just, even though that's ideal and will get you the best bandwidth, that's probably not what's coming immediately. Okay, wait, and here's like the big like leak, maybe, right? Google, I mean, everyone knows like Google dropped TurboQuant, right? And everyone's been asking me like, why did Google drop TurboQuant? Well, it's because DRAM prices are insane and Flash is 50 times, 55 times cheaper than DRAM right now. Just despite the Flash price increasing, right? So Flash could probably price higher and higher and still, offset DRAM. So Google, it's leaked that they're actually that for the next TPUs, they're not just making a TPU, they're making a memory accelerator. Now, we don't know who Sandisk's customers are. They won't tell you, right? But it's definitely the big hyperscalers. I don't think they would have embarked on this HBF journey and this investment if they didn't have a customer in mind. I think it's interesting that Google is so against these because they're getting hit the hardest on these DRAM prices that um that they're willing to make a memory accelerator. I think that memory accelerator will probably be like a high bandwidth flash or a array of flash memory packaged very neatly and offloading a lot of AI to it. I think
What do you mean
yeah.
memory accelerator?
Oh yeah, so like it's kind of like a weird concept. I didn't hear about a memory accelerator until like this year too. So what it is, I mean, like we have like AI accelerators, but AI needs a lot of memory, and
Yep.
also the way you interact with memory in AI is a little different than a generic computer running an OS, right? There's like different tiers. There's your queries, there's your weights, there's files, there's context. So what Google's probably going to do is really offload a lot of this memory that would have went to DDR to Flash and do something very smart with it to get the similar amount of speed up as they would have gotten on DDR or faster, right? So
Mm.
do you know like Google was the first to really um pioneer like these long context models? I think Gemini still has the longest context, 2 million, right? Well, you can't fit 2 million tokens per user on these
Mm.
GPUs. I mean, you'd need a shit ton of GPUs and aggregate across. If you think about it, if Flash is 55 times cheaper than DRAM, how much cheaper is it than HBM? It's probably like a thousand times or 2,000 times, right? Okay, it's cheaper. Now, if you can get the bandwidth up to like HBM2 levels or equivalent with some very smart tricks, I think the people at Google who are on that team are very smart. Maybe even smarter than me sometimes, right? So I think they definitely know what they're doing and they're not into this DDR cartel. They don't want to like negotiate with these like for lack of a better term, like these Korean terrorists, right? Who are making this DRAM, right?
Yep.
So I think you will be shocked when it comes out what Google makes. I have no insider info, but I can read the tea leaves
Sick.
and tell you with good confidence what they're probably going to do. So
Sick. And then obviously
yeah.
users want infinite context windows.
Well, users probably do want infinite context windows. I mean,
Yep.
so I don't want to go into this too much because I might be doing my own thing on the side, but yeah, like yeah, if you really look at it, right? Why do we need 288 gigabytes of HBM? That sounds kind of crazy. Like, bro, like we could like play Counter-Strike on like 150 gigabytes, of storage, and all of that is context, right?
Yep.
And context is exploding. I've had this argument with a lot of people when they say, well, agentic workloads, they don't really care for context because you can just make the tool call. But I'm like, Well, a large code base, you're doing like a complicated model in Excel or some complicated computer task. Like, yeah, you can make a call to a tool, but that's going to add latency. The context is going to be faster. And also, context right now, I mean, this is what's led to the growth of DDR and Flash because it's growing so much. We need to serve so many users at long context, and they all want to do these coding and agentic workloads that they're spilling to DDR. It's the only economical way, and then they're
Yep.
spilling into Flash, and now we have VLLM, right? To even make this manageable. So I feel like what people aren't understanding is that we're getting a third tier of memory. We had like when I was in school, they taught me L1 cache, L2 cache, L3, DDR, disk. Okay, that makes sense on one CPU or one laptop, but now we're at the multi-rack scale. And now it's gonna become a new tier of memory and maybe even a new tier of networking to communicate that memory across all
Mm,
these racks. I mean, you have thousands of racks with GPUs and they all look like one computer to someone, right? Like that's kind
yep.
of like crazy. Like that's a real testament to the engineering being done here, right?
Yep. Sick. Next one, broad category. There's multiple in there, so maybe pick the one that is high, if any. Wafers.
Mm, I don't think we have much of a shortage of wafers.
Cool.
I think wafers are interesting reticles, which make the patterns of the chips. I think we don't even have a shortage there, but what we have a shortage of is like quality, right?
Yep.
When people go to these higher end, like high NA EUV nodes, the reticles need to be completely redesigned. So it sounds like this basic thing. I think the wafer's basic, right? Like we have our 12-inch wafers and we've been using them for years. It's kind of served us good. No one really wants to redesign it right now, but the reticles, every new generation of litho is like a completely new reticle design.
Mm,
And getting those reticles right is huge. Well, I mean, I just know this from my own experience of like taping out a chip is like the biggest cost when you tape out a chip is the reticle, is getting that reticle made. Cost millions before you get it perfect. And then
mm.
voila, you start doing your tape out. So sorry for the rant.
No, this is good. The next one, PCBs.
Ooh, interesting one. So again, the PCB that you would use for like your Arduino, no, we got that down. But
Yep.
what we're seeing is because packaging, like advanced packaging is tight, and also they can't scale it past, well, right now, I mean, Vera Rubin Ultra was supposed to be four reticle dies stitched together, and now it's two reticle dies and another two reticle dies communicating over a PCB. Those
Mm,
PCBs, which need to be multi-layer and have very good signal integrity, those are definitely in shortage because it's a
mm.
quality problem. And
Yep.
my guess is if Nvidia is still stuck on TSMC CoWoS and they can't figure out how to do advanced packaging better on there, it's going to lead to even worse
Yep.
scenarios on PCBs where Nvidia might need
Yep.
all those high quality PCBs. And it's not just the PCBs, it's literally like I could find some of the companies if you give me a sec, but even the materials in the PCB, like the
Mm,
glass fibers that they use for shielding different layers, those have gone parabolic. There's like one or two companies in Japan who can do it, and there's no one else. Like that
mm,
is an actual structural shortage, and everyone's trying to find someone else that they can get these data center or these PCB high quality glass fibers for PCBs, right?
mm.
And there's like three or four really good like PCB companies in like Taiwan and Japan, and that's really it, who could do this mass manufacturing of like hundreds of layers of PCBs. So I would put PCBs as pretty tight, and the
Yep.
materials for them even worse.
Yep.
And if we don't solve these packaging issues, it's going to go from bad to evil.
Yep.
So if you want to make money, make a PCB company right now, maybe.
Yep. Do you want to? Yeah, I'm curious which those companies are.
So I can give you a few right now. Unimicron's the biggest one
Yep.
in Taiwan. There's Gold Circuit Electronics in Taiwan, who makes all this, high speed PCBs. There's a couple. Nanya PCBs in Taiwan is very good as well. In Japan, there's a couple of these other ones. I think Unimicron, no, not Unimicron, Unitaka. Unitaka is like the funniest story of all time. It's literally like a loom. Like I don't even know what a loom is because it's like back from like the 1700s, right?
Yeah, yeah, yeah.
They make fibers,
The
right?
weavers.
Yeah, they're weavers. They're weavers, right? And like it's basically been a zombie. It's a zombie company. It's this old 300-year-old Japanese company.
No
And
way.
they make like fibers for like textiles, plastics,
And
shit
now
like
they're
that.
weaving glass.
And now, well, they already did do it, right? They already weaved that, but they couldn't get the it wasn't a big part of their business, as you can imagine, right? Now all the hyperscalers in Nvidia are going to them and they're like, yo, you got to expand this and get qualified so we can use you for these PCBs. So we can source these glass fibers from you. So it's
Mm.
like the funniest story of all time. It's like you could write a movie about it. It's literally like a 300-year-old dying Japanese weaving company drowning in debt. And if
Yep.
they get qualified to make these glass fibers for PCBs, they will like save themselves. Like they will become an AI trade company. And it'll probably be good enough that they can like exit most of these other businesses, which are very like commodity businesses, right?
Hmm. It makes me think of Toto, and there's just these other companies where they have some skill that they've developed for a different kind of product, and
Hmm.
now all of a sudden they get pulled into the AI space because they have what AI compute needs.
Oh yeah. So Unitaka, like looked at their stock movement over the past year. It's insanity. We're talking like 100% moves in days,
Yep.
right?
Yep.
Up and down, because no one knows if they're gonna get qualified. And if they do, we really have no idea what is gonna do to like their revenue and the impact.
Yep.
So it's a very exciting time to be a Japanese investor, I think.
Yep.
Yeah.
Um, Next one would be power, just generally power delivery.
Mm. So power sourcing is tough. Honestly, I mean, you've already seen like Elon was willing to go to Louisiana to tap into the freaking biggest gas pipeline in America to use it, right? I mean, that's a smart move, but I feel like not everyone can do that. So
Yep.
power is tight. Doing deals with these utility companies is going to become way more common.
Yep.
Now, as we like it's kind of been telegraphed, and the big trade now is like we're transitioning from like 48 volt to 800 volt DC architectures. And that whole supply chain is also, I mean, we're not there yet, but people are now like rushing to figure out how to solve that. So you
Hmm.
need all kinds of transformers, inverters to deliver 800 volt DC between racks.
Hmm.
So I think there it's pretty tight on the real power side. Like just raw power, it's tight. People are thankfully working hard to figure out 800 volt before it comes online, but it's just going to get worse. So like
Yep.
power is getting bad,
Yep.
probably in the future. And the power that the GPUs are using is like not increasing by like 10-20% a year. It's like doubling. So yeah, I mean, I think my biggest bets right now are on power, but not directly on like, you know, small modular reactors and stuff like that, even though I think this stuff is very cool. It's more like, how do you deal with this power? I don't think anyone knows.
This is more of the how do you move 800-volt power between
How,
racks, you mean?
how do you move it? More also like once it's there, how do you like not burn the data center down? Like, how do you keep things cool and calm?
Hmm.
So I'm not gonna spell it out, but I think one of my tweeted about this already. So one of the companies that I was like very bullish on, other than Intel, but I didn't want to give it too much credit because it was a small company. I'm like, I didn't want to manipulate the price. But it's this company called Flex,
Yep.
and Flex makes, data center equipment, cooling equipment for data centers. But they do it for everything, right? From hospitals to anybody who needs huge amounts of power. But what Flex has is within that company, they have these very, very smart cooling solutions for chips, which it's not just normal water cooling blocks or cooling. So, like, even the transformers that you're going to be using need to be cooled. Even the
Mm,
power rails need to be cooled at 800 volt, right?
mm,
So I think they are doing a really good job of like seeing that future. But I think they only have a roadmap up to like Feynman. After that, we actually have no idea how we're going to cool things. No one has
mm,
an answer.
mm.
There's some views, but again, this is a 2 year away problem. And hopefully by then, me and you are both just chilling on the beach and we don't have to worry about it too much. But I feel like no one really has an idea of how to cool these chips. Even
Mm.
at 5 minutes, it's going to be tough
Yep.
to cool them.
Next one, optical fiber.
No, it's not in a shortage.
Cool. Next one, liquid cooling.
Quality liquid cooling. No, it's not in a shortage either right now, but it kind of goes back to my prior point, which is um we have no idea how we're going to cool things in the future. So yeah, it's going to be a problem in a year or two, or whenever Feynman comes online.
Mhm. Yep. Um, outsource assembly and test.
Pretty big bottleneck, I think. I think th it can definitely be expanded. There's a few companies, but I think it probably needs to be like quadrupled if you think advanced packaging and photonics is coming online. All those need insane testing, and not just testing at the wafer, in the package, right?
Hmm.
So once it's packaged, that's real testing.
Hmm.
Forgot the
This is
name of
like
it.
Rigaku. This is like what
Yeah,
insane or irrational analysis is
yeah,
telling me.
yeah.
So,
The air test is the other one that a lot of people point to. ACMR does testing, but they have a big China exposure.
yep.
There's a couple companies, although like it's not my
Veritas, how do you
main.
spell that one?
AEHR is the ticker,
Okay,
but
yep, cool. Yep.
air test.
Oh, air test. Yep.
Yeah, so burn-in testing, which is like when you have all the packages up and you're pushing these crazy voltages, you want to make sure nothing blows or explodes.
Yep.
So you're going to do testing in the package. I think one thing I haven't heard about, like a good reason why I haven't, is because in photonics, fiber coupling, which is like connecting the fiber to the die, is like a big problem because you'll
Mm,
get coupling loss. Now, all right, so free to your viewers, we could ask Claude later, but what are the companies that are good at like fiber coupling? I don't think there are any because it doesn't
mm,
really exist right now. It's like being hand done by like some experts in like a university lab, right? Or like the one or two like photonics only fabs, and those are really just university labs at the end of the day, right?
yep.
So fiber coupling is going to be a big problem if you think photonics is going to scale. And I don't
Yep.
think there's like an automated way to do that.
Next
Um,
one would be CPUs.
CPUs are probably medium.
Cool.
I think
Yep.
we will see if advanced logic gets expanded. I think CPUs, I think it's already been telegraphed that AMD might have just been like F3 nanometer, like we're just gonna move some shit to 5 nanometer right now, just to meet this demand. And I think people will eat it. They don't really care. They just need more
Mm.
CPUs. They're
By
probably
advanced
willing to
logic, do
take
you
it.
mean lower nanometer scale?
Yes, yes. So
Yep.
like anything below like TSMC 5 nanometer, I consider advanced, right? That's
Anything
what.
below N5, you said?
Yeah, correct.
Yep. Whereas they're just going to push it up to the higher nanometers and it's good enough kind of thing.
I think that so most of these like server kits will use here, right? But they don't use it for everything. Like you don't need it for everything. For compute, you need it, but for IO and
Yep.
other
Yep.
things, you can get away with like even
Yep.
6 nanometer if you wanted.
Next on hard drives.
Ooh, pretty bad, I think. If
Mm,
you're meaning like spinning disk hard drives, I don't think there's any way they're really expanding capacity on that. The only thing that they can probably do is like add more bits to the hard drive, which I think
Mhm.
there's a way you could do that when you're manufacturing. It's almost like more voltage levels in Flash. Although I haven't done much research of exactly how they do it, but I think a spinning disk is like completely in shortage. The question is though, um, like spinning disk kind of competes with Flash, right? So like we will see
Mm.
what people decide to use.
Data center land and shells.
Thankfully, in America, we have a lot of land.
Yep.
So I think power and water are the
Yep.
constraints for the
Yep.
land. We have a lot of land. I think every like we can just like fill up Texas with every data center imaginable, do data center like make like barges in the water of data centers if people have a problem.
Yep. Power semis.
They're not in a shortage right now. It's like the most like hype trade that everyone's doing. There's not a
Yep.
shortage, and they're very like mature nodes that like anyone could make. And my guess is like if it does become profitable, China's just gonna flood the market with tons of power. I mean, they already do with like knockoffs, but yeah, I'm not in the power semi trade right now. Actually, it
Yep.
technically was, but it's not really my focus.
Yep. How do you, let's say 2 or 3 years from now, what do you think will be most, or how would you rank the three of HBM, DRAM, NAND in terms of kind of, pricing power?
Pricing power is interesting question. I think pricing power kind of follows usefulness. So let's just rank by usefulness. I
Cool.
think NAND is number one. I think there's not much more supply. There's only like a handful of fabs. Like Toshiba's a big one, Kiox is the other. Um, and they're not really into like expanding more right now. And there's not really a
Yep.
need to because people are willing to pay another 100%, 200% because it's still cheaper than DRAM. If you also think NAND is going to become way higher bandwidth and way more useful, voila, its pricing power is amazing. If it's just as fast as DRAM and cheaper, it's a great thing to have. Um, Two would probably be HBM. And the reason I say this, even though I said before HBM prices are kind of stabilized or somewhat down, it's because they keep want to push more and more stacks of HBM. So I think it's like
Mm.
16 or 18 high now, and they
Yep.
want to go higher. And now they're trying to do like co-designed HBM with Nvidia. So they're going even off of the standard for
Mm.
HBM, which is set by JDEC. So I think whoever cracks that nut is going to make a lot of money, and people will pay a premium if they crack it, right?
Yep.
I don't know. I think if from our whole combo from now, you can kind of understand that we're hitting thermal limits of physics right now, right?
Yep.
And it's probably like Feynman's like, where do we go next, right?
Yep.
Um, and third, yeah, DRAM. I mean, I just think China's going to flood the market. CXMT is going to flood the market with DRAM. I think in July, TSMC might expand logic nodes, which is going to lead to even more HBM needed, and it's going to just make the price of DRAM go from bad to worse, and people are not going to take it anymore.
Yep.
I think we could literally see like the big cloud companies team together and make their own DRAM fab.
Yep.
I
Yep.
I think it'll get that bad. If they don't expand capacity, they're gonna lose. Yeah.
If they don't expand capacity, they'll make it, you said.
Oh yeah, like if Samsung and SK don't expand capacity, like
Your
they
mic is
will.
your mic was just
Oh,
going a little bit out there.
sorry. Can you hear me better?
Yep.
If Samsung and SK don't expand capacity, the customers are just going to be so pissed off. They'll get it from CXMT. And if China tries to block them, I mean, if the US tried to block them from buying from China, they'll just say, F it, we'll make our own. We'll do a joint venture.
Hmm.
And there
Yep.
is precedent for this, believe it or not. So in Japan, I think this happened once.
Hmm.
So let's see how it goes.
Interesting. Next one would be technologies that have become much more important over the past 12 months that you expect to
Mm,
continue increasing in importance.
Absolutely, packaging is number one.
Yep.
Packaging is the new Moore's law. It's our only way to scale compute today, and
Yep.
there's no other option. So packaging is number one. Two, it hasn't really gotten important yet, but new cooling
Yep.
techniques, right?
Yep.
Whether it's direct die cooling, like microfluidic style cooling, maybe two-phase cooling could be used. Um, this is going to become extremely important.
Yep.
Let me think of third. I always say this to people as a joke, but I really mean it. Like the way you're going to change the world is make a new kind of memory or cure cancer. So like memory and specifically I think flash. I'm so bullish on flash and I think it's a memory technology that scales and is relatively cheap. I think that's become going to become important. And I think we're going to see all kinds of
Mm,
advancements in memory from here, right? I think we're going to see very like it's going to look like a different world.
sick.
We are probably like there's the
Yep.
big like John Hennessy computer architecture book. I have it right here on the side to me.
Mm,
Throw it out because new things are coming. Like none of that stuff is going to matter anymore. The line between compute and memory is going to get blurred.
yep. And that's partly because if we want faster tokens and longer context, it's just memory bottlenecked.
Yeah, and all it is really memory bottleneck. Also, like,
Or your mic is going out again.
yeah, apologies. So it is memory bottleneck. Also, it's just we haven't had innovation in the space. HBM and
Yep.
stacking is like one way, but
Yep.
we're gonna see crazy stuff in memory. I'm very excited to see what people do. I was like a VC. I would just go to anyone who has a good memory idea and try to give them money and just hope that they pull it off because they will become, you'll go down as a legend, if you're that guy. You're winning Nobel Prizes for this stuff. So yeah, it's very
Where do you
exciting.
think the like hardware founders will come from? What is the like, what San
Very good
Francisco is to
question.
AI, you know, enterprise startups or consumer startups? What is the equivalent for in the US, especially of hardware companies
Yeah,
like that?
it's such a good question, man. I'm in Palo Alto right now, right? So I'm not in SF, and I probably spend most of my time in Palo Alto, Sunnyvale, Cupertino, San Jose, and I meet all these engineers. So that is like South Bay and San Jose. I mean, this is Silicon Valley, and thank God, I feel like a lot of people think America's lost like the chip race because Taiwan and these people can manufacture chips cheaper. What people don't get is we have some of the best chip designers, not some of the best chip designers in the world. No one compares to us. The only people who come second is the UK, but even them, like
Hmm.
they don't have the industry we have. They don't have the amount of startups, the amount of like big companies. They have ARM and maybe a couple others, but that's really it. And that's the only reason why the UK kind of has this chip legacy. It's gonna come from these engineers who are working at these big, like behemoth organizations. Like
Yep.
counterintuitively, I
Yep.
don't think they're gonna. They may not be like Stanford undergrad
Yep.
dropouts.
Yep.
They'll be like PhD, got kicked out of my
Yeah. Yeah.
PhD,
Yeah.
or dropped out,
Kind of
or they're
similar
gonna
to the Grok kind of founding team, that kind of
yeah,
stuff.
yeah. They're gonna be like these guys who are just like, bro, I've built my career for so many years and like, F it, man. Like, I'm gonna do my own thing. It's
Yep.
gonna be like they're gonna be like the archetypical founders, I think. They're gonna be like these guys where like if you talk to them, you're like, yo, like like what's wrong with this person? Like why is this person is gonna be like a Steve Jobs kind of character because I think making hardware is hard, and the
Yep.
only people who are still doing it are doing it because they love it.
Yep.
And
Yep.
and hardware engineers are like basketball players. They're like, I'm the best, man. Like you're not on my level, you know?
Yep.
I think it'll be a very fun time to back hardware.
Any chip companies you like? Like there was Fractile, I think it was a UK one. Then there's like
Yeah.
Positron, Etched, MatX, Taalas. Any do you think could be doing, work at scale in like 5 years?
So I can't say too much because I know all of them and I've talked to all of them. I will say, um, 2 years ago, I was definitely of the opinion that we need a general purpose AI accelerator, right? Like a GPU or something even more general than that. I've completely changed my tune on that. And I think specialized is the way to go. The market's big enough. that if you can specialize even in one niche of AI compute,
Mm.
you're gonna win so much. So I'm very proud of my friends at Etched. I think a lot of people have, maligned them maybe online, but I've looked at what they're doing very closely. And from what I've gathered, and I don't know if they're gonna like this when I say this out when this comes out, but I feel like a lot of NVIDIA's innovations are just like etched ripoffs at this point. Like even NVIDIA's tensor cores, they're just taking stuff that Etched was doing maybe a year or two ago and just being like, yeah, maybe a specialized like attention kernel makes sense, right? So I'm definitely of the feeling that the more specialized you go for your niche, the better. Um, I'm very proud to see what they're going to do. I'm actually meeting them later today.
Nice.
So I wanna see how things go there. As far as the others, I mean, there's not much info out. I think Taalas, from like a scientific standpoint, is very interesting. Um, I think Taalas maybe will need to partner with someone though. I don't think they should stand up their own compute. They should kind of license that IP because it is very interesting. And I think it has uses way far beyond AI. I think it so Taalas, for maybe like the listeners who may not know, is like they basically found a way where when you have a reticle with your chip pattern, they can burn in the weights, but when you want to make a new chip or change the model, you don't need to change the whole reticle. You can just change a small amount. And remember, I said reticles are the most expensive part, and voila, new model comes out on a chip, right? Now, do I think burning the weights into a chip, even if you want to think inference is the future, is the way to go? Maybe no, but burning some stuff is probably useful. And I think having that flexibility is very important in the future, right?
Yep.
But
Partner with someone, you mean they should partner with someone to as like an inference cloud, or you mean they should partner with someone on the creation of the chips themselves?
the creation of the chips, I think that IP is interesting and that know-how is interesting. And they should be licensing that to like every hyperscaler, Broadcom, Marvell. Those guys can definitely find where to use it better than they can.
Yep. Yep.
I'm also of the opinion that like selling chips may not always be the best idea for these hardware models. I think if you're trying to sell into a data center, there's two ways you can do it. You could be niche or something that NVIDIA hasn't fully captured. If you're going after compute, it's hard, right? But if you're going after like networking or like memory offload, like people are willing to work with you, but you have to integrate into their ecosystem. I
Mm.
think Google's done I mean, every major cloud's done this, but Google's probably done it the best where they want to own that stack. Maybe the thing with these new hardware startups is partnering with someone who doesn't have that stack, right? And those are the big AI labs, right? That's
Mm.
Anthropic and OpenAI. That's smarter because they don't have, I mean, I've heard that OpenAI has a hardware team, but I haven't seen much come out yet. But
Right.
they are more willing to work with you if you design for that.
Hmm.
That might be a smarter use case. Or the other use case, which I think helped Grok a lot, was stand up an inference API. If your hardware is definitely better on TCO,
Yep.
start selling tokens, right?
Yep. Yep. Next one would be emerging or technologies that are going to be very important in the coming years. So not haven't seen it as much yet. So maybe HBF is one here. What else?
Even though I'm pretty bearish on like co-packaged optics and photonics, I think if they crack it would be great, you know. So
Yeah.
I really
Do you
hope they
expect
do.
problems with the kind
Oh
of
yeah. Oh yeah. Oh yeah. I expect next year most of the rollout, most of these things will probably fail. And because of the economics of having to buy these expensive ass Lumentum lasers all the time,
yeah.
um, and any other thing in there that the hypercloud or the large cloud companies are just gonna say, nah, we're good. We're just gonna go back to like cheaper switches right now.
Hypercloud. That would actually be a good name for the category. That'd be
Hypercloud is
sick.
probably the better category
Do
than
people
what
say
about
that?
hyperscaling? I just made it up right now.
Yes, that would be better, right?
I'm on
It should
like
be
4 hours of
neoclouds.
sleep, so
It should be
well,
neoclouds and hyperclouds, obviously.
I like hypercloud.
Yeah,
Maybe we'll make it stick after
I
this.
think that could be good. When's HBF, like when do you think HBF kind of comes online?
We're getting samples at the end of the year. We'll probably figure out uh Q2 of next year of when the production starts. I'm very excited to see what comes out. Again, like just as an EE myself, I just want to see this field push forward. So
Yeah.
anyone who's really investing and taking a chance, taking a risk to push computing forward, I love it. I'm not a big bottleneck investor. Like I told you, the PCB and these fibers, like I'm not invested in that. I want to invest in innovation. It's a very
Yeah.
like VC mindset applied
Yeah.
to public markets.
You're excited about Compute Express Link?
CXL, oh yeah. I think Nvidia is not excited about CXL, but I know Google is and everyone else is. I think CXL and HBF go hand in hand. Because
Mm,
again, if you believe there's going to be a memory accelerator, it's going to use CXL. Because
yep.
to anyone who doesn't know, CXL just makes all of your peripherals that would have been on like PCI just look like memory, just look like RAM. You don't have to worry too much about it. The programming model is great. Um, Way less latency, and it makes all these things communicate a lot easier versus PCI.
Would that be like Astera? Is that kind of the a
Oh
company like
yeah,
there?
I definitely was very long Astera, yeah.
Yeah.
But like it could not be Astera. It could be Broadcom. Like I mean, we will see. CXL is an open standard, right? So we will
Right.
see. But I think people who are building on CXL, right? People who are making a CXL switch. People who are making CXL cards. They're going to be the winners, right? Like
Yep.
CXL
Yep.
is a standard.
Can you say more about the voltage of packages for new chips?
Okay, let me find my phone because I want to get this. I want to get this right for you. Okay, so typically in data centers, we were distributing 48 volt DC, and
Yep.
now we're going to 800 volt.
Yep.
I have the numbers of like the estimated power draw, right? So for Rubin, the power draw is 2,200 watts, which is 2.2 kilowatts. It's estimated for Feynman 4.4 kilowatts, right? So it's basically double.
Yep.
I know right now that in the cooling market, I don't think anyone really knows how to go past like 4.5 for cooling.
Yep.
For post Feynman, we're at like 5.9 kilowatts. And
Yeah.
for whatever comes after, 15
We're fucked.
kilowatts.
Yeah.
And these numbers come from my
Yep.
friends at the Korean Institute of Advanced Technology, CASE, best school in Korea. Let's go, CASE. But yeah, yeah, bro. Like I look at this and I just think of like, is someone telling me like a joke? Like, is someone trying to pull the wool over my eyes?
Because
Again,
you feel like the people that are increasing the voltage are just not talking with the people that are having to cool the chips, and that's why you kind of care about both. You care about cool. Basically, it's like everything that can get more density on a chip, which increases volt,
yeah,
increases power, and then everything that can cool that power.
yeah. So like in my eyes, it's just like, yo, we're hitting the limits of physics. Jensen's telling us we're gonna double compute. And he's done it so far, right? A200 to B200, roughly a double. Rubin should roughly be a double. Feynman should be more than a double. But then after that, I'm just like, wait, like what's going on? Right?
What's the most important ratio, by the way, for cooling? Is it amount of power per square foot, or is it just amount of power? Is it amount of power per something?
Flux. It's flux. So it's like heat
Power per
flux.
flux
It's flux. It's
or
flux. Like
flux?
flux. Yeah, flux is like heat traveling through an area. Like flux is like traveling through a again, it's been a while since I've been out of physics, but flux is basically the rate of change through an area, right? The surface area,
Okay, yeah,
more or
okay,
less. So heat flux, right? Which is basically how much heat is moving within a unit of area, right?
okay.
That's the thing that just makes I mean, and that's just derivative of how many watts you're pushing into it too, right? Um, the more watts you're pushing in, the worse the flux gets. Um, so yeah, I think this is a big unknown, honestly. We are so if any VCs listen to this, looking to some cooling companies, looking to
Yep.
anyone who can solve this problem because this is a
Yep.
real problem.
You want to see new memory companies, you want to see new cooling companies. What other kinds of things should engineers at all of these South Bay chip companies be starting?
They work on getting the reliability of photonics better,
Reliability of what?
photonics and optics
Photonics
better.
reliability. Yep. Yep.
Um, I think also just work on like maybe this isn't like an engineering thing, but like maybe the math and AI geeks can like figure out like some unique ways so we don't need to use as much compute, right? Like sparsity, TurboQuant to me is like an amazing innovation. A lot of people say, hey, it's nothing special. We've been looking at ways to compress KV, but um, I think that's kind of a more of a leap than the other techniques we were doing in the past. So I think we need innovation on the algorithmic side somewhat, which should lead to the right hardware innovation. I think TurboQuant opens up the way for memory accelerators and all these things, right?
Yep.
So
Two things we can do next, and then we'll do the other one afterwards. We could do favorite X accounts and this kind of stuff, or we could do rapid fire opinions on different companies.
let's do rapid fire and then we'll do the favorite X accounts
Perfect.
after.
I'll go through some of your ones first. Let's see. Um, Obviously, you're still very bullish Intel at this point.
Of course, yeah.
Yep. Um, Nvidia.
Over promise and under deliver is the slogan for Nvidia. I think Jensen is the best semis trader of all time. I think he knows where all the bottlenecks are. Just follow Jensen and you'll find out. So that's my view on NVIDIA, and also
Yep.
somewhat innovative, but very stymieing the innovation at this point by having a lot of these closed standards, and
Yep. Yep. Yep.
anyone who does anything innovative, they won't adopt it for their architecture anymore because they don't own it.
If you were Jensen, what area would you try and lock up next, or has he kind of done all the important ones at this point?
I would lock up Intel's EMIB capacity
Yep.
if I was Jensen.
Um, TSMC.
Too conservative, will lose market share.
Too
Um,
conservative on investing in improved advanced packaging, mainly.
Very much so. A little set in their ways there. I think also too conservative with not expanding capacity fast enough for advanced logic. I
Yep.
think a lot of these memory issues we're seeing here would have probably been solved if TSMC expanded it earlier. And I think they will expand it again in July.
Yep.
I think we just need them to double the fat, right?
Yep.
So.
Alphabet.
So I don't know about all of Alphabet, right? But Google is definitely, I feel like a lot of people hate on them because Gemini lags or whatever. But I mean, Gemini's job isn't to chase benchmarks, it's to set what the new benchmark is, in my view. I think the hardware, like most of the innovation right now is coming out of the TPU team and Google. Um, Other than like agentic workloads. We'll see when they launch something now,
Yep.
and I think they'll make a lot of money and they'll be fine. They're probably one of the few like big tech companies which I have no worries about. And it's weird because SaaS has completely fallen off a cliff. All that's left now is like Hyperclouds and apps,
What's
right?
fallen
So,
off the cliff?
SaaS,
Oh,
B2B
SaaS. Yeah. Yeah.
SaaS.
Yeah. Yeah.
Yeah. So
Hyperclouds and chips. Exactly.
Hyperclouds and ads. Like that's where you want to be in the software landscape. You want to be in the
Oh, yeah.
cloud and
Yep.
you want to be selling ads,
Yep.
right? Which is why Meta's still doing well.
The 5 years from now, how much of Google's TPUs are they using internally versus selling or renting?
I like 25-30% internally.
So heavy external. The
Yeah,
your is your view that kind of Google's in an advantageous position LLM? What maybe actually a better question is Google, OpenAI, Anthropic, 5 years from now, do you feel like they all are similar in terms of frontierness of their models, or has one broken away significantly?
Mm, that's such a good question. I think Anthropic is just making so much money right now, and money solves a lot of problems, sadly, that
Mm.
they may break away and it might turn into an Anthropic versus Google thing. I think OpenAI, even though they were definitely the first to come out, and I'm not saying to count them out, but I'm just saying at this point, we're transitioning from the aspect of high burn to high capital appreciation, right? And I don't think they've appreciated that. They still think that they're trying to capture market share at this point, which we are, but you also need to start now making money so you can ensure you have compute and resources for
Hmm.
the future. You can't just burn capital. You actually have to have a plan for getting it, for accumulating it, right? We're going
Yep.
from burn to accumulate. And if you can accumulate faster than you can invest it, you're going to be in a very strong point. And Anthropic and Google are both there.
Yep.
They're just crazy capital accumulators, cash flow accumulators, right? I think
Yep.
OpenAI is still just trying to like invest in compute, capture market share, burn at a loss. And I feel like we're transitioning from there. I
Mm.
think the future is these tokens are very profitable to serve, right?
Yep.
And you have to make money eventually.
What's the point where you are no longer bullish on Sandisk?
Hmm. When Sandisk management makes fuck ups, when they are not like adding value to their customer, I think that's when I'm not bullish. I will always be bullish Flash as a technology that could scale in the future, right? But the good thing is, Standis is kind of like really the only game in time right now who can serve the needs in Flash, right? We have Micron and technically Samsung, but they're not really pushing the needle there. SanDisk is only Flash, right? So that's their main business. I will be not bullish when we get a CEO in there that says, "Hey, I'm actually returning money to shareholders. Hey, actually, like we're gonna go longer term contracts on Flash." And actually, I'm just going to cut staff and
Hmm.
like make things cheaper so we can get better margins. I do not care about that. I want them to innovate. I want them to push it. And I think they know that Flash could be innovative. I don't think they're dumb about this. They're not playing the game that SK and Samsung are doing where they just want to price gouge DDR, right? They're playing the game of let's be innovative. We made this
Hmm.
money, let's take a risk now, right?
Yep. Yep.
So
Amazon.
I view on Amazon a little all over the place, honestly. They have a lot of business lines, but I will say, I
You
mean,
you could also do just on their chips as well if you wanted.
well, Tranium has kind of like not shipped too well. I think they've had problems ramping up their next generation of chips. But I will say, if your view is that tokens are like the new electricity or oil, the money is going to accrue to whoever has the infra to serve it the cheapest. And it's interesting. Anthropic's, all their cloud models are basically hosted on AWS, AWS
Mhm.
Bedrock, and all these other things, right? And OpenAI made a deal to go onto Bedrock. And they kind of have like this like institutional like access point where like if you're on AWS Bedrock, like institutions will just use you. Like,
Yep.
like the
Yep.
big banks just trust you.
Yep.
So I think there could be an angle where like Amazon and maybe Microsoft. I don't know about the others, but Amazon, I definitely think they're thinking like, hey, yeah, we might be burning money and not growing too much, but like we're getting people addicted to like our cloud and we're cheap for hosting. All of that big like enterprise market share that Anthropic's winning is
Yeah.
because they're on AWS, right?
Yeah.
And I think that gives them a lot of power in the future. Right
Yep.
now, it's a little iffy, but they may turn around and just say, "Hey, you know what? Like," and they've already Andrew Jassy's already mentioned this in his earnings calls. Is like if I spun out Tranium, it'd be like this big of a business. And
Yep.
there's a big thing with these huge companies is there's little kernels in there that are just so valuable,
Yeah. Yeah.
but it
Yeah.
gets diluted by everything else. Flex was like that story too. Like it's like this little cooling block
Yep.
that like is so important, but the rest of the company kind of dilutes it.
Yeah.
We could see in like 5 years from now that a lot of the value accrual might go to the people who own infra and can, just like AT&T charges you for internet and your phone, they're going to be charging you for your token bill.
Yeah. It's funny, the Amazon thing makes you think that they'll right now they're going to distribute, OpenAI and Anthropic tokens, and then eventually, eventually they'll do Amazon Basics tokens.
Maybe, yeah. Or maybe they just go to OpenAI and Anthropic where like didn't like scale out their own compute and just say, hey, guess what? We're taking a portion now.
Yep. Yep.
So
The distributor. Um,
yeah,
Next one, ASML. When do you anticipate that we would see? It seems like memory makers have exercised their pricing power. ASML hasn't as much, but presumably has a lot of pricing power. Um, do you anticipate that it would exercise pricing power?
they don't have any pricing power, sadly. I
Hmm.
don't think so because the economics of a fab are like when you buy this machine, you have to run it all day to get your money back, right? And people are very cautious because it's a huge capital expenditure, and people are very cautious about expanding capacity right now. So, like,
Mm,
what pricing power does ASML or the other wafer equipment tools really have? I mean, like, it's just like the customer's going, your machines are too expensive, and we don't need to buy that much right now. I'm not trying to flood the market today, right?
yep. Yep.
And ASML's like China was a big part of their business, like the growth in their business, and now they can't sell EUV tools to China. I mean, let's see if they get locked from selling DUV tools or anything else to China, which could happen. I don't think they're in a good place. I don't think there could ever be really a structural shortage because who holds the cards? It's TSMC and now Intel and Samsung to
Mm,
an extent. And they're not like aggressive growth maxis. Like they're not, they like high prices. They like having control. They like
yep.
setting the price. So
Yep.
it's tough. It's tough for ASML. I will say ASML is trying to expand into advanced packaging now, which I think is
Mm,
very smart. We'll see how they do, but if they actually do a good job of expanding into it, I can see them taking a lot of market share. So we'll see. But right now, litho is just not expanding in line.
yep. Hynix.
Mm, Hynix. I think Hynix is probably going to continue being the best like HBM supplier and the best advanced memory supplier if they're doing HBF. Um, so I think they definitely have a niche there. And if you think memories and innovation in that space is important, SK is investing and taking risks to do it. So I think they'll still maintain their position, but without expanding DRAM supply, they might actually shoot themselves in the foot, and cause a bunch of pushback that they don't want in the long term.
Because they'll create competition for themselves, basically.
They'll create competition, but also they'll just lose goodwill. Like after a certain point where like things are in a very, very, very bad shortage, like you will get demand destruction.
Yep. Yep.
Like 32 gigabytes can't cost me $10,000, right? Like
Yep.
it
Yep.
becomes uneconomical to use.
Are you still long Lumentum at this point or rotated out?
No, 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 no. Definitely sold out of Lumentum.
Yep.
While ago, like a month or two ago.
Important
I think not the
technology,
best
but just
move.
everybody kind of gets it, basically.
Well, also, I mean, the procurement cycle is kind of done. We're going to see these switches come online at the end of the year. Let's see
Yep.
how they do. If they're a screaming success, then definitely own Lumentum. If you see that people are willing to like replace these lasers and replace these switches, that's not my view. But if
Yep.
it is true, I mean, yeah, Lumentum's great. Lumentum has the best lasers for this use case.
Yep.
So
Yep.
we will see.
Is that you feel the same way then about AXTI and AIXA?
For now, yes, but again, they're just making indium phosphide, as I understand. So that will eventually get competed away.
Nokia, and
Yeah,
Infineon in
and
particular.
Nokia is interesting because Nokia is like everyone knows Nokia is a telecom company, right?
Right.
But telecoms like they actually have to do like crazy high bandwidth data manipulation. It's the same stuff you got to do now for data centers. So like all these like data center interconnects are probably going to be using like Nokia or competitors, but Nokia is the best at this like high bandwidth data movement, right? And they need to for
Mhm.
telecoms if you're doing 5G, 6G, low latency latencycycycycy communication, right? So the data center business is going to grow quite a bit. We'll see how they do. I don't have a pick as far as who wins what, but
Yep. Yep.
I think they can become a very important data center company with all
Yep.
of the networking infrastructure there.
Wolf.
I sold Wolf before joining this meeting today.
No way.
Yeah, literally,
Just because it
right
feels
before.
too frothy now? Or?
Yeah, and Wolf. So like Intel is my biggest position in my portfolio right now, and Wolf today surpassed it. And I was like, okay, something's weird's happening with Wolf, right? Like it just went up so much that it surpassed it, right? I was like, let me rebalance. I mean, we'll see. I think Wolf is basically in a short squeeze right now.
Right.
We will
You exited
see.
completely or you kept a bit?
No. I had to rebalance. I had to rebalance because it was just too big
Okay.
of a
So you
position
still
at that point.
still hold some, just much smaller.
So for context, like Wolf was probably up like over 100% for me.
Yeah.
So it was just too much.
Yeah. Enphase and Solar Edge.
Mm, I don't have an opinion. I've heard of the names. I know why people are maybe a bit bullish because
Yep.
of the inverters for DC, but I don't have an opinion as far as like who's good or who's not.
Yep. Semtech.
Again, I can't give you an opinion. I haven't
Cool.
studied
Rigaku, that's the X-ray inspection stuff.
it. Um, I haven't looked at Rugaku terribly close, but inspection. And I forgot, there's a specific term for this where like you test things with light, like for inspection of wafers. Um, it's definitely an interesting space to be in.
Cool.
I think it's an interesting product offering.
Sumimoto and IQE, you would kind of feel similarly, wait for the CPO rollout.
Yeah, yeah, probably.
Yep. Navitas and Texas Instruments.
Again, don't I can't tell you which. I mean, if you're a trader and like everyone just wants to pick which one uh to buy and make money off of, it's probably going to be Navitas because they're just like a shittier company. And when good news comes to shittier companies, it just makes them it saves their lives, right?
Yeah, totally.
So like Texas Instruments is like a very mature and fine company. And,
What about the
if
gallium nitride?
yeah. I mean, like I'm an EE, right? But like even like as you're gonna find out, like I'm the digital chip design kind of person when it comes to power and signal processing and all this stuff. I will defer to people who are smarter than me. But I mean, it's important. But the question is just like, okay, like they're not the only people who can do it.
Yep.
Um,
Yep.
so what are you betting on? Like what's your point here? Like I just want to buy companies that like if they disappeared like they would like break your heart if you're trying to stay at the data
Yeah.
center, right? Like that's how you know someone's adding value in your
Yeah.
life, right? Like what if
Yep.
this guy just like took a vacation for 3 months? How would I feel?
Yep.
I don't think anyone would really care if Navitas took a vacation for 3 months.
Yep. The what was your process for building conviction in Intel? You talked about you went to New York, pitched a few hedge funds on it. When did you first see it? What was the thing that made you go from like, oh, this is interesting to like, oh, I'm actually going to put a large portion of portfolio in? How much time did you spend trying to convince other people? What were their reactions? That kind of stuff.
It's a great question. So what led me to build conviction was the reason why Intel has like previously crashed quite a bit was that they were investing. And what were they investing to do? To overtake TSMC. Now, from our whole convo up to now, you know that I kind of like when companies are like taking a risk and trying to like add
Yeah.
value to the marketplace, right? Like,
Yep.
but to the finance community, that just tells you negative free cash flow for 2 years. And
Hmm.
I've been evaluating this company for like 5 years as an analyst, and I
Yep.
just care about free cash flow and EPS, right?
So you're
But
like a
what I
technology VC perspective on public.
Oh yeah.
Yep.
Like I almost never like I will look at valuation to like if it's like really bad or like really high to understand what's going on. But my main view is like, what's my view of the world of like technology and what's going to happen? And it
Yep.
was clear like we needed an alternative to TSMC. It was clear that they could do it, right? I mean, they fabbed their own chips up to now pretty successfully. They've invented most of the semiconductor industry up to this point has kind of come out or spun out of Intel, right? Including silicon photonics, which people don't know. Like they were the first to really invest in that.
Mm.
So I'm looking at this. I'm looking at a company basically that's valued less than their assets, right? So I could have bought the whole company, sold their assets, and theoretically made like 10 or 20%. And I was like, okay, this technology, like high NA, UV, 18A, like it's like it doesn't need to be world beating day one. And I think the market doesn't get that. Like you don't need to beat TSMC day one. You just need to be second best maybe at first and have good
Yeah.
quality and good customer relationships. So
Hmm.
that was where I was like, this is an obvious long. There's no risk. Even if they became bankrupt, I would have probably made 10 or 20% on my money, right? But I was also just bullish. I knew what high NA what the benefits would be and what maybe some of the drawbacks could be. I knew their innovations in like backside power delivery would lead to total like efficiency dominance over TSMC as far as like wattage. And again, I think wattage matters more, like power matters more now than even flops at this point, right? And that's why Apple's went onto Intel for their laptops and stuff. Because they may not be better on as far as like density right now in 18A, but they're definitely better on power and no one
Mm.
can take that away from them. And that matters quite a bit.
Hmm.
Then you're looking at like, okay, were they executing? They were. You know, the 18A PDK came out. It wasn't perfect, but you know, it was good. It was decent. 18AP, which just came out recently, was announced in like some conference recently.
What was the
They
process like where you were kind of going through all this stuff? This was like you're doing a lot of reading, talking with friends of yours that are technical, talking with friends of yours that play in the public markets.
Yeah. So my process was literally reading everything I could find on lithography, and
Yep.
especially high NA versus just low NA, and how many layers of EUV would they need to compete with TSMC. So it was all my own reading and research. And at the time, I honestly wasn't talking to any friends. One thing I think people don't know is like I actually don't try to talk to people for like investment ideas.
Mm.
I try to avoid that as much as possible because I really don't want anyone clouding my judgment. I'll talk to them about technology though.
Yep.
So it was kind of obvious to me that they were positioning themselves to be strong and they just had like a balance sheet issue.
What was
It
the
was
time period between when you first kind of started diving in to like once you developed enough conviction to have a big position? Like weeks or months or shorter, longer?
it was like a month maybe. So I think January of 2025
Yep.
was like when Intel was really at their lowest, probably. And like they fired their old CEO. There wasn't a CEO in place. Then Luc Bouton came took over. So right then is when I was like, okay, well, I
Yeah.
definitely know the company is undervalued completely. It's basically valued like it's going bankrupt. It's not.
Yep.
I know their technology roadmap is good. And then I knew that they didn't have to just be the best fab. I mean, Samsung's shittier than Intel right now, and they're still alive as a logic fab, right? Um, so I just knew like the technicals were
Yep.
there. And to me, it's like when you know you're right, you when you absolutely know you're right. Like most of the time we don't know that we're right. Like we don't know what the demand for GaN is going to be or if silicon photonics is going to work. I arguably do not know these things. You know, I'm very aware of what I don't know. But I knew for sure that Intel was being valued below the value that they are making, right? And that they would not go bankrupt. So it was very easy for me to just put all my money into it.
Yep. Yep.
And from there, the thesis played out perfectly. At the time, packaging wasn't in my thesis, but soon I started understanding about the packaging, and that's when I quadrupled down
Yep.
on packaging. And
Well,
18A shipped fine. 18AP is now amazingly like 30% better than 18A. 14A is basically almost done. 1.0 PDK probably next quarter, and it'll probably be volume production sometime next year. So it was a no-brainer for me.
What made you go and pitch it to funds?
Well, I was just like people because I streamed so much about it. People were like, "What's wrong with this guy? Like, why does he like Intel so much?" So people would chat, and then like I was in New York at the time, so friends in New York would like be like, "Yo, my friend's really into Intel. You should talk to him." And I would tell them my idea, and they're like, "All right." But it was when Trump, when the government took a stake with the CHIPS Act money, when they asked for equity instead of a loan,
Mm.
that's when they started listening to me a little bit. And then once I got really right, like once like the target announcements, everyone was like, "How did you see this?" So a lot of people passed, by the way. There's only one guy who heard me out and immediately like made it the biggest position in his fund. I can't tell you his name
Sick.
because he's anonymous, but really good friend of mine, and he's done. Like if you what's the word for it? Like economically, yeah. Like
Economically independent.
no, it's not even that. It's like post-economic. That's the
Okay,
word.
go yeah.
Yeah, he's post-economic at this point,
Yep.
off of Intel. So yeah, so shout out to him. And then of course, the big funds ended up talking to me later and they're like, "What do you know?" They thought I might have had insider info. I'm like, "No, actually, you can just read these papers that come out in these conferences yourself."
Yeah.
So
The next one, I think your answer to this might be none, but do you pay for any news or info sources or?
I pay for Bloomberg Terminal.
Yep.
I don't ever use it. I actually just use it to message my friends in finance sometimes for fun
Yep.
and get
Yep.
them in trouble at their job.
Yep.
I use it sometimes to like look at like nice little graphs. Other than that, I really just use Twitter. But like even like the Bloomberg terminal, right? Like I kind of got it just because like if you get a meeting with someone like a big bank and they want to lend you money, like who is this guy, right? Like they don't really know who you are. So it kind of got me a little legitimacy, right? Sadly, like that's how that world works. But the main value is being on Twitter and talking to people who are engineers. Like I just want to talk to engineers who are experts and who can teach me.
Yep.
That's the value. Don't read like research. I mean, like semi-analysis is great, it's fun to read their research, but I'm trying to understand the technology and what happens when something changes. Not,
Yep.
I'm not trying to predict who's gonna win what or when's DDR gonna roll over, yada yada. Like there's smarter people out there than me who can figure that out, right? I'm trying to find what's the next big thing.
Yep. What are some of the X accounts that you most often read their stuff?
So I like Zhukan quite a
Yep.
bit, but Jukon's just like a friend. Like I like chatting with them. I think like I run chat on Twitter. So chat's like the best electrical engineers in the world. It's like 200 of them. And they're all like the most cracked people ever. So you can just go there if you ever have like a technical question on like photonics or just chat with some people in there. They'll tell you. But like Lucas Grosjean, he's very good in photonics. Let's see. Outside Five Sigma is by far my favorite account for technical info. By
What
far
was
one
that
of the
one again?
smart
Outsize.
outside Five Sigma. Yeah, outside
Yep.
he's a good friend of mine, one of like my favorite people to talk to. There's a couple others that'll come up, but those are the main ones. I'm trying to think who else. Vikram, I think everyone knows Vikram's kind of been doing a good job. So Vikram Sakar, I really like
Yep.
Vikram's Substack. But I mean, these are like some small accounts. Lithos. Oh, so Lithos Graphene or something?
Yep.
He's
Got
a
it.
real, he's a real, fab engineer doing research on this stuff. So he'll give you info that like you would never think of. And
Mm.
then Lori Wired, who's a very big account, right? I really like reading her tweets because
Yep.
she's extremely technical and knows what she's talking about. So yeah, those are the main people I like to follow.
Sick. Any other Substacks that you tend to read most of the stuff that
No,
goes in your inbox?
no. No.
Cool.
Oh, I will say there's one analyst that I really like though. He just got on Twitter. His name's Jeff Pu. He's like an analyst in Hong Kong or something, like a sell side analyst. Like he works for like a bank or some kind of like, brokerage. But he was one of the few people who was really bullish on Intel.
How do you spell his last name?
It's PU, I think. Jeff Pu. If you look up Jeff Pu, you'll find it.
I think I found it. GF Securities.
Yes, yes, yes.
Cool.
So Jeff Pu to me is the best semiconductor analyst. Um, and he's gonna see things other people don't because he's in Hong Kong. He can meet
Yep.
with these Asian companies all day.
Any other
There's another
analysts? Yeah.
small account like Mohammed Zuhair, but Mohammed was really early on Intel as well. And I think he has the best coverage on Intel specifically.
Cool. Yep. The any discords or conferences or things like that?
ISCC maybe. International Symposium of what do you call it? ISCC? Yeah, International Solid State Circuits Conference every February, and then SPIES in September. So if you want to learn about optics and photonics, SPIES is great. And Computex, which is coming up in June, but that's more of an industry conference, like not academic.
Yep. The any the answer to this is probably no as well, based on your style that it seems you have. But any investors where when they take a position in something, you're like, okay, I'm going to give this a serious look. Just like the fact that they have a position makes it worth my time to dig in.
Absolutely not. I think Druckenmiller maybe in the past,
Yep.
Stanley Druckenmiller, but
Yep.
Stanley's a generalist. I would probably look at like what he does maybe in macro trades, not
Yep.
really single stocks.
Yep. Yep. Any publications or projects in your future? And a related question to this is, what was bubble computing?
So it might still be happening right now. Like
Okay.
I said, I really like Flash, so
Yep. Yep.
I want to
I,
get in the Flash game.
last question. Anything I should have asked that I did not ask?
That's like the best question. Maybe the question is like, why care about any of this, right? Like, why are we like extenuating so much energy on this and
Yeah.
researching it and killing ourselves? I think part of the answer I think a lot of people might want me to give is like, I can make money off of this. But honestly, if money was your only motivation, you got to like sling SPVs in San Francisco or something, right? That's like a way quicker way to get some cash. Um, I mean, I just think like we're living in like a new computer revolution. Like we lived in this in like the 80s, probably in the early 70s. And that's when like, Intel was the growth. Intel was the open AI, right? Like Cisco was like the big company. Now Cisco's going crazy. So we're in like a new computer revolution. And I would just tell people like CS was like the big thing, computer science, programming. It's still very much important, but I think now we're realizing that the problems we're hitting are like on the edge of physics. We're bumping our heads on it. So we need to like go back to first principles and learn this stuff. And I
Yeah.
think now's the most exciting time to be doing engineering because we're at the limit. Like
Yep.
we are at the edge, right? You're not
Yep.
redesigning like the little chip in your iPhone just for fun, right? Like you're not doing incremental changes. We have to rethink computers and architecture and how we've been doing things from first principles now. And it creates so much excitement now. I think you said like people follow me like it's a TV show at this point. Well, I follow some of the computer stuff to me like it's a movie, right? So it's very exciting. And I think a lot I think let's not get lost from the fact that like, we really are in like this computer revolution thanks to AI, right?
Yep. Sick. Yeah. It makes me think it's like the demand is so strong that now it's like we have the need for genuine new innovations. And it sounds like that's the thing that gets you
Oh yeah,
excited.
because all this stuff about like new memory architectures, photonics. Photonics has been being researched in like academic environments since like the 90s. People have been like designing this stuff for years. It's just now we've reached the point where like, F it, man, give it a shot, right? Like let's
Yep.
let's try to do it.
Yep.
So I think it's so exciting for me as someone who's like always loved electrical engineering and the stuff on the limit, right? So it's
Same.
very exciting.